You're using an invoice management system. You click Delete. A confirmation window pops up. Are you sure you want to delete this? You click Confirm. Then you delete another one, another pop-up appears. Confirm again. At this point, you're probably thinking, why are there so many confirmation windows? But this is actually standard UX design for delete operations. We do this because developers are terrified of one thing: users accidentally clicking the delete button. But here's the funny part. Even with confirmation pop-ups, users still accidentally delete things, and this is where the real nightmare begins. Imagine your system is using something called hard delete, meaning when the user deletes something, the database record is physically removed forever. Not hidden, not moved into recycle bin, just gone. A few weeks later, your support team receives an angry ticket. Why is my record missing? Did someone hack my account? Is your system randomly deleting data? Now, the scary part is the user actually deleted it themselves, but they genuinely forgot. Or maybe this is a shared company account. User B deleted the record, but user A has no idea and now thinks the system is broken, so your team starts investigating. You check the code, no bug. You check the logs, nothing suspicious. You check the database. The record no longer exists. Then comes the second scenario. The user admits they accidentally deleted it, and now they're begging you to help recover the data because otherwise their manager is going to destroy them in tomorrow's meeting. But your system uses hard delete. At that moment, you and your user both stare at the screen in complete silence, realizing there is absolutely no way back. And this is why hard delete is both powerful and terrifying. It's simple. Just run a delete statement. No extra storage usage. But once the data is gone, there's no recovery, no audit trail, no evidence, and no protection for your team when something goes wrong. So developers created something smarter: soft delete. Instead of physically deleting the record, we add extra columns like is deleted, deleted by, and deleted on. Now, when the user clicks delete, we don't actually remove the data. We simply mark the record as deleted. Suddenly, everything changes. The angry support ticket comes in again. My data disappeared. But this time, you calmly open the logs and say, "Dear customer, your teammate John deleted this record on May 10th at 2 a.m. Absolute evidence. And if the user begs you to recover the data, just set is deleted back to false and boom, the record instantly comes back to life. This is also why many enterprise systems directly show activity logs on screen for team accounts. Instead of forcing support teams to investigate everything manually, users can immediately see who deleted what and when it happened. Fewer misunderstandings, fewer support tickets. Now, soft delete introduces a completely new problem. The deleted records are still inside your database forever. Your tables become bigger. Queries become slower. Storage costs increase. And every single query now needs to remember, oh right, filter out the deleted rows. Over time, your app slowly becomes heavier and heavier. So how do we solve this? First, indexing. Imagine you frequently search users by username. Instead of indexing the entire table blindly, you can create a filtered index that only indexes rows where is deleted equals false. Now the database can instantly skip all the deleted garbage and search only active records super fast. We'll dive deeper into indexing in the future, so subscribe if you're interested. Okay, performance problem solved. But now we still have another issue: storage. Database storage costs real money. We cannot keep deleted data forever until the end of humanity. So companies introduce something called a data retention strategy. Maybe every midnight, a background worker automatically runs and checks which deleted records are older than 30 days. Those records finally get permanently removed using a real hard delete. And this is where software engineering suddenly collides with business decisions. Because many SaaS companies actually turn retention policies into subscription plans. Free plan, deleted data recoverable for only 14 days. Pro plan, 90-day recovery window. Enterprise plans 7-year retention for legal compliance and auditing. Because retaining deleted data is expensive. Bigger databases, more backups, more infrastructure, more compliance requirements. Suddenly, even a simple delete button becomes connected to architecture design, scalability, legal requirements, infrastructure cost, and monetization strategy. And we're still not done yet. Now, let's enter the next level, relational data. Imagine deleting a folder that contains 100 files. If the folder disappears, should all the files disappear too? This is called Cascade Delete. With hard delete, it's easy. You just configure on Delete Cascade in the database. Delete the parent folder, and the database automatically deletes all child files too. Now, let's combine Cascade Delete with Soft Delete. You soft delete the folder. What should happen to the 100 files inside it? First approach, soft delete everything together. Folder deleted. All files deleted too. Sounds reasonable until one day the user restores the folder. Suddenly, all 100 files come back as well. But then the user says, "Wait, I deleted this file months ago individually. Why is it back again?" So, many systems use a safer approach instead. Only soft delete the folder. Do not touch the files. Then during reads, you simply hide files whose parent folder has is deleted equals true. Yes, this makes your queries slightly more complicated, but it massively improves consistency and prevents weird accidental restorations. And this leads to one of the most important lessons in software engineering. Never blindly use Cascade Delete everywhere. Because delete behavior is not just a technical decision. It's a business decision. Different relationships need completely different strategies. For example, imagine an e-commerce system with product categories and products. If you delete the gaming chairs category, do you really want all the products inside it to disappear too? Probably not. The products are still valid. They just no longer belong to a category. This is where another strategy becomes useful. On Delete Set Null, meaning when the parent category gets deleted, the products stay alive, but their category ID becomes null. Later, admins can simply assign them into another category. But sometimes, you don't even want the parent record to be deletable at all. This is where onDelete Restrict comes in, meaning if child records still exist, the delete operation is completely blocked. Imagine a banking system. A customer has years of transaction history. You absolutely do not want someone casually deleting that customer record because audit trails, legal compliance, and financial reporting are critical. So the database itself says, "Nope, delete denied." And finally, there's another strategy that many beginners don't even realize exists: data anonymization. Sometimes privacy laws require companies to erase a user's personal information. But fully hard deleting the record might break analytics, reporting, or historical statistics. So instead of deleting the record, we anonymize it. Replace the name, prepend something like deleted_user_123, scramble the email, and remove the phone number. Now the system keeps its historical relationships and reporting integrity while still protecting user privacy and complying with regulations. Everybody wins. And this is why deleting data is way more complicated than most people think. What sounds like just a delete button is actually connected to user experience, database design, legal compliance, recovery systems, infrastructure cost, team collaboration, and business strategy. So next time you design a delete feature, don't immediately reach for hard delete. Think carefully about what should disappear, what should stay, what should be recoverable, and what the business actually needs. Because in software engineering, even deleting something can become an architecture decision.